Welcome to a lesson with Dr. Powell. Let's take a look at simplification of fractions. All right, so let's suppose that we have something like x plus 1 over y plus 1. A lot of people would be tempted to see, well, I see something the same in the numerator and denominator. They think, well, let's just cross out those ones. No, we don't want to do that. This is not equal to x over y. You can look at lots of examples of that. For instance, with x is 2 and y is 3, that would be x over y. But then when you put that x and y in here, you would end up getting 3/4. And of course, those guys are not the same. Okay, so that's something we wouldn't want to do. Okay, so we can't just simplify this like this. This is as simple as you can go. So what can you do with fractions? All right, so let's look at something in a factored form. 2 times 5 times 3 over 2 times 2. Now a fraction is a ratio. What can you do with the ratio? You can multiply both parts of the ratio by the same thing or divide them by the same thing to maintain the ratio. And that's basically about all you can do with fractions in terms of reducing them, or at least equivalently. That's what we can think about. So for instance, we could divide top and bottom by the same thing, dividing by 2. Now dividing by something just means, like, if it's in factored form and you see it, is the same thing as like getting rid of it. Like undoing the multiplication by it. So we can undo the multiplication by 2 right here, and we can undo the multiplication by 2 on the bottom just once, because I'm only dividing by 2 one time. And then we're left with 15/2. Okay, because we've done the division, right? So after doing the division, those 2's go away, and you're left with 15/2. All right, so next, let's move on to something that looks a little bit more fun. What if we had x over y plus 4 all over x over quantity y plus 4 squared, and then we have plus 1 over y. Using this exact same idea, so you see this big fraction bar and these little fraction bars. This big fraction bar means there's something above it and something below it, but you can't interchange these things, right? So this bar and this bar it's important to realize that these are different sizes and mean different things. If you interchange them, you will get something completely different. Okay, in terms of what's happening. I mean, intuitively, you have something up here and you're seeing how many of these are in it. Okay, so what we can do to top and bottom right here is we could multiply by the same thing. Just like we could divide the same thing to top and bottom, we can multiply the top and bottom by the same thing. So what should we multiply by? Let's multiply by something such that when it multiplies in or distributes through, we're going to get some kind of cancellation, just like you see this cancellation here with the 2's. So we could multiply by, I'm going to choose this and then we'll look at it. Y plus 4 squared y. Y plus 4 squared y. You could say that this is the least common multiple of all the denominators that you see occurring inside of the fractions that are inside of the big fraction. Okay, so this guy, that guy, and that guy, what does least common multiple mean? It means it's something that's a multiple of all these guys. It's as small as we can think of. So a multiple of y plus 4. So a multiple is something that has this guy as a factor. Well, this definitely has that as a factor. Also has this as a factor and that as a factor, right? Now, why is that nice? Well, let's see. When it multiplies into the top, you can think of the top as simply being, this guy is a numerator guy. So if you multiply in any fraction, a times 1 over b, this a essentially goes up to the numerator. Now I could maybe make this something different, like c, because what is c over b? C over b is the same thing as saying we have c of something, c 1 over b's, right? And so we have c of something, and then if we're multiplying a in, we're basically saying a times c of those things. So a will go to the numerator place. So we can think of this as strictly going to the numerator. And if you'd like, you can even extend this fraction bar and think of it like this, with the times and a times. Then you could think, okay, well, notice we have a common factor. We can cancel common factors out just like we could here. We can't cancel things that are added on, but we can factor things that are multiplied on, because division undoes multiplication, or multiplication undoes division, but you cannot do anything with pluses just when things are multiplied together. So here we have y plus 4 quantity squared, y plus 4. Notice we can get rid of one of those factors, get rid of this guy. So on the top, and notice, wow, over 1. That's the same thing as not really talking about anything, because 1 into something, and like something divided by 1 is just the something we started with. So basically the top has just become what we have right there. So the whole top part of the fraction is simply x y plus 4 times y. What about in the denominator? Let's make sure we use parentheses properly, okay? So especially since I have extended this fraction bar, I needed those parentheses right there. Okay, so this is going to multiply in. How does it do it? It distributes. It distributes to both parts in a similar way that we did up here. When this comes in and multiplies to the 1 over y, this is like in the numerator. Notice the y up top and the y down below will cancel out. You'll be left with only y plus 4 squared when we distribute to this term right here. Okay, so we have y plus 4 quantity squared. Now, when we distribute into this guy, notice the y plus 4 quantity squared, y plus 4 quantity squared, those guys will cancel. And we're left with y still being the numerator, y times x. So we just have xy plus y plus 4 quantity squared. And we'll stop there with the simplification. Why does this fraction look simpler? Well, because it doesn't have fractions inside fractions. And we'll just kind of leave it like that. In fact, you know, keeping things in chunks or factors as much as possible is also fairly simple. I would discourage multiplying things out too much unless we need to kind of go in and refactor it or see if there's a way of doing so. But if that's not important, I would discourage against that. This is actually fairly simple right here, right here. So there's a lot of people use the word solve when they're doing something, but that's incorrect unless you're solving for a particular value that should be associated to a variable in order to satisfy an equation. Usually what we're doing is we're rewriting. We took an expression to begin with and we rewrote it in a simpler form. Sometimes that's called simply simplifying. Simplifying an expression. An expression is something where it's just like a number, or it could be a number represented with lots of variables and some operations put together. There's no equal sign. We're taking expressions and we're simplifying them. Thanks for watching.